Doing well for the preparation of your upcoming CIEs 2026. Guys, here I'm going to discuss the second part of paper number 5 mock exam 2026. Here the question number 3, A we have done in the part 1, the B. Find the probability that Sam's first successful attempt will be before her fifth attempt. So before her any fifth attempt, he will be successful. So here I can say the probability of the from first part, probability of attempting a goal is 0.7. So I wrote it 0.7, and probability of not attempting a goal is 0.3. So here, if it is for the first before her fifth attempt, it means x must be less than or equal to 5. We have to find the probability of this one. So I can say it can be, probability of x is less than or equal to 4. So either I can write 1 minus q power 4. I will substitute the value here by applying this formula. 1 minus, instead of keep going on fifth and onward unlimited attempts, I will finish my results with 1 minus q power 4. Q is 0.3 power 4. I will calculate it, and in the calculation I will get answer 0.9919, or you can write it 0.992. That is your final answer for this case. Okay, the third part. We is a member of the same soccer club. He is also practicing scoring goals. The probability that we will score a goal on any attempt is 0.6, independently of all other attempts. We is going to keep making attempts until he scores 3 goals. Until he scores 3 goals. 1 goal, then 2 goal, and when he will make third goal, then the experiment will be finished. He will be successful then. Find the probability that he scores his third goal on his 7th attempt. Yani 1, 2, 3, 4, 5, 6, and 7th. Here 7th attempt, here he makes the third goal, G3. It means for the first 6 attempts, he has he has 4 failure, 4 failure plus 2 goals, success. Goals, that means success in the first 6 attempts, right? Because third goal he said he has his in 7th attempt, so he will be successful in here. So for the first 6, he needs to choose selection. Like first of all, I can say the probability of 4 failure is what? Any failure is probability of success is goal is that is given. Probability of goal is, or the success is 0.6. Here it is given. So probability of failure is 0.4. So for the first 6 attempt he will fail for 4 times. So I can write probability of 4 power 4, and probability of 2 success in the first 6 I can write 0.6 power 2. Now it is not even finished here. I will write the probability of third goal in 7th attempt. You have to calculate this, and that will be, first he will be any failure in 4 attempts, and in first 6 he will be successful in 2 attempts, times these numbers can be shuffled because he can make a goal in the first 2 attempts and rest 4 will be failure, or first and third attempts and rest it can be shuffled. So I can say out of 6 factorial, I can say 6C2. Out of 6, 2 will be successful, times in 7 attempts for sure he will be the third success 0.6. So here we can solve this on the calculator now. This is what because the successes yani 1 2 3 4 5 6, because for 7 for sure it is successful. So he can successful here, he can be successful here and here. They are going to repeat, the selection is going to be tossed up for the first out of 6, 2 successes can be tossed up. So I can write 6 c 2 times 0.67 success, and once I will do the calculation I will get the answer here, that is 0.0829. Okay, now the next question says, question number 4, a summary of 50 values of x gives this, find the standard deviation of the value. Okay, this same formula we can get, standard deviation of x will be sum of square deviation divided by n minus sum of x minus q by n whole square and square root. Okay, here this is 1 4 2 3 5 by n is 50 minus 700 divided by 50, then whole square and then square root. Game of calculator, we can use a calculator to get the answer and you better can do the calculation by yourself, and I will get it 88.7 square root is 9.48. That's my one of the answer. Question 4, part A. Part B, given sum of x is 2865, find the value of q. We are given this x minus q is equal to 700. So apply the property of expansion of sigma sum. I will write sigma x minus nq is equal to 700. Sigma x is what we are given, this value. This is 2865 here from here, minus n is 50q is equal to 700. So 50q will be 2865 minus 700 is 2165 divided by 50. I will get the answer 43.3. That is the value of q. It's a simple bonus question. Okay, now question number 5. Okay, on any day, Kino travels to school by bus, by car, or on foot with probabilities 0.2, 0.1, 0.7 respectively. Okay, the probability that he is late when he is traveling by bus is x. Probability that he is late for when he is late when he is traveled by car is 2x, and he is late when he is traveled by foot is 0.25. Okay, the probability that on a randomly chosen day Kino is late is this. Find x. So better to discuss this with the tree. It's easy to make understanding of it. He has 3 mode of transportation: by car, by bus, first bus, car, or on foot. Respective probability: by bus is 0.2, car is 0.1, and foot is 0.7. And then there is a possibility either he will late while traveling with bus or he will not late. By car same goes, late or not late. By foot, late or not late. So the probability of that he travels by bus and late is x. So and not late will be 1 minus x. And he travels by car and late is 2x. So 1 minus 2x is not late. And by foot is 0.25. So it means 0.75 is not late. Okay, this is simple tree. And probability that is late, with all 3 modes he can be late. So I can write probability of late by bus and late, or car and late, or foot and late. Do replace the probabilities, and that is given to be 0.235. It is given here. Probability of late. So bus is 0.2, late x, car 0.1 and late is 2x, foot 0.7 and late is 0.25, that is 0.235. Now you can simplify this by simple calculations and we get 0.4, yeah, 0.4x, because this and this makes same, and this product goes to the side to become subtracted one, 0.06. So x will be 0.15. This is the first part, 3 marks, simple case. Second part, find the probability that on a randomly chosen day Kino travels to school by car, given that, so it means dependent events, he is not late. So probability of not late, bus and not late, travel by car and not late, or foot by not late. So here I have 0.2 times not late is 1 minus x, mean 1 minus 0.15, either you can write it directly, plus car is 0.1 times 2 times 1.5 plus, sorry, not 2 times, 1 minus 2 times 1.5 is 3.03, plus foot is 0.7 and not late is 0.75. So we can simplify this to get the final answer. In the calculator we will get this, the probability of not late only, that is 0.765. But here it's not finished, because it's conditional probability that given that is not late, we calculated it. Kino lates to school by car. So if he travels by car and late, school on a Saturday, Kino travels to school by car, that he is not late, by car and not late. So it will be car and not late. I will write 0.1 times 1 minus 2x, 2 times 1, oh sorry, it's not 3, 3 times 0.15, right, 0.15, so 0.45 times 3. You can simplify this to get the answer, that will be 0.07. So the probability that is traveled by car and not late, L prime, is equal to probability of C intersection L prime given probability of, as we are using the formula here, 0.07 divided by 0.765. On the calculator we get the answer 0.0915, or yeah, even in fraction 14 by 153. Both are right. That's the answer. A simple case study. Okay, now question number 6. Yeah, the length of western blueberries are normally distributed. This is a case study of a normal distribution with mean 16.5 and standard deviation. Standard deviation is this. So a random sample 150 these birds is selected. How many of 150 birds would you expect to have length between this and this? It means probability of, if I say random variable x is between this is less than x is less than 16.8. You have to calculate this thing, but given that x approaches to a normal distributed with mean 16.5 and variance 0.6 square, because it's standard deviation, so I will write the square. Okay, here I need to change this into standardized variable, so I can write standardized variable formula, you know well, I will writing for you. Z is equal to x minus mu upon sigma with normal distributed with mean 0 variance 1. So here it means 15.4 minus mu is 16.5 divided by sigma is 0.6, and this x change into z, less than, then 16.8 minus 16.5 divided by 0.6. We have to calculate this one. So I will get these values, and on the calculator the simplifying value will be minus 1.833 less than z is less than 0.500. So that is the same as phi of 0.500 plus, just keep recalling the rule I explained, minus 1. Okay, let me explain you again with the figurative case. This is a case study. Here minus 1.833, here 0.500. So as case study for the symmetrical distribution, this minus becomes, you have to calculate this area, na? So this value will be here the same as 1.833 positive 1. So from the table I will get these value from here to here and from there to there. So apply the rule on from the z table. From z table, one value is here negative, one is positive, so that says sum of the two z table value minus 1 will get this. So from z table I get the value, and when I will add them and subtract it with minus 1 and 0.658, this is the probability of any 15.4 is less than x is less than 16.8. But this is not my final answer. Reason, here he says how many of 150 birds would you expect to have? Expectation, we need to find the expectation here. For the expectation, for expected number of birds between this range, we will need multiply this probability with how many? N is 150. So 150, and we'll get 98.99 approximately, and or is 99 is the final answer here. I hope it is clear. It's a simple case, very simple case. Now the next one is the length of eastern bluebirds are normally distributed with mean this and mean this. 18 point x is normally distributed with the mean 18.4 and standard deviation is sigma, so it's variance sigma square. It is known that 72% western bluebirds are having length greater than this, meaning probability of x is greater than 17.1 centimeter is 72%, 0.72. So normally distributed with standard deviation of this. Okay, this is given, and that means 72% means 0.72. I can write like this. So change this one into the probability distribution. Probability of z it goes to be x minus mu. This will change into x is 17.1 minus mu is 18.4, and sigma square is sigma greater than 17.1 is 0.72. So it means here, if I draw the table figure, 0.72 is here, 0.72 greater value. So not here. This is the value greater than 0.72 here. From here 0.72 greater value because big area. It means 0.28 is lying here, and so this is the area, shaded area covers 0.72, so total area is 1. We have to calculate this value of z here. a value of that is 17 point any z value for which give us this area. So we will go for the, this time we are given the probability, so we will use the inverse table of z, and here it will be probability of, it will be minus 1.3 over sigma, greater than 17.1 is 0.72. So inverse table of 0.72 we will see, and that is minus 1.3, that is equal to z. Z is minus 1.3 by sigma. So as lying left, z is lying left of mean, so its value will be in the table. Within the table we will see, and I will get it 0.583, but as z is lying left of 0, so it will be negative. So after simplifying, I will do this, minus minus cancel, 1.3 over 0.583 to get sigma as 2.23. This becomes the sigma. Simple case, because probability is given and it's 0.72, 72% is covered, more than the big area of the portion. Only 28% is left over, and we have to get the values bigger than 17.1. So this whole shaded area we are looking for against this value is 17.1. So we get it from the inverse table, we get the value of sigma. I hope it is clear. Now let's proceed for the C part. A random sample of 120 eastern bluebirds is chosen. Now 120 eastern birds is chosen. Use an approximation to find the probability that fewer than 80 of any 120 birds have length greater than 17.5. So here we know this is approximation, so we know that approximation from binomial to x approaches to any binomial approximation to binomial is NP, approximation to normal. Let me write it. First of all, case is approximation from binomial